In common sense, time always moves forward. Years, months, days, hours, minutes, and seconds, the occurrence, continuation, and end of all events seem to connect to a moment of time and can be recorded. The sun rises and sets, the seasons change, and the clock ticks. Whether you are awake or sleeping, things around you are always changing and developing, and time is passing by. This is our intuition. Time and 3D space that humans can perceive are empty and invisible, like imaginary coordinates. In space, objects can move forward and backward, left and right, up and down. They can also move or remain still, move fast or slow. The degree of freedom for time is much smaller. It seems to move forward forever, passing at a constant speed, from the past to the present, from the present to the future. This video will look into the familiar concept of time, examining its nature and human perception. Hope this content will help us build a beneficial view of time. In this episode, we first look at time in modern physics. Albert Einstein, 1879 to 1955, famous physicist. He published his special theory of relativity and general theory of relativity in 1905 and 1916. The theory of relativity revolutionized people's understanding of time and space, and derived the mass-energy equivalence equation. The theory of relativity explains that time does not exist independently of space, but that space and time are a whole. Space can become larger or smaller, and time can also become faster or slower. In terms of time alone, the faster an object moves, or the stronger the gravitational field it is in, the slower the time passes. This is called time dilation. After the theory of relativity was proposed, with the advancement of science and technology, the phenomenon of time dilation has been repeatedly proven by advanced experimental instruments. In 1971, the Halfel-Keating experiment used 12 cesium atomic clocks, 4 of which were placed on a plane flying eastward, another 4 on a plane flying westward, and the last 4 remaining on the ground. After the experiment, the differences in time lapses of the 3 sets of atomic clocks were calculated, and the results were consistent with the calculation by relativity equations. In 2010, the National Institute of Standards and Technology, NIST, in the U.S. did an experiment for time dilation using a more advanced atomic clock and measured the impact of a 30 km/h change in speed and a 30 centimeters change in altitude on the passage of time. Once again verified the relativity theories. In 2022, the Gila Laboratory in the U.S. made an even more advanced atomic clock and verified the red shift phenomenon caused by the slowed vibration frequency predicted by general relativity. This atomic clock was said to have an error of only 0.1 seconds in 14 billion years. Such high accuracy can also help detect gravitational waves or dark matter. Satellite positioning systems, like GPS, compensate for small differences in time caused by time dilation at the receiver to achieve high positioning accuracy. Today's smartphones have GPS chips. This might be the closest application of time dilation in our daily lives. Since many experiments or applications have proven the time dilation effect predicted by the theories of relativity, an interesting question is raised: can immortality be achieved through this method? The question is simple to ask, but the answer is not intuitive. Using the formula of special relativity derived by Einstein, we can estimate how much the speed of an object affects time dilation. When the speed reaches 1/10 the speed of light, time will only expand by a negligible 0.5%. And when the speed reaches 1/2 the speed of light, time will only expand by about 15.5%. Only when the speed reaches about 90% of the speed of light, time will expand to more than 2 times that of a stationary object. And when the speed reaches 99% of the speed of light, time will expand more than 7 times. The speed to escape the Earth is about 12 kilometers per second, and the speed to escape the Sun is about 17 kilometers per second. The solar system flies through space at a speed of 200 kilometers per second. The speed of light is a constant of 300,000 kilometers per second. Manned spacecraft have only visited the moon so far, and the speed is less than 1/10,000 of the speed of light. A relatively easy way is to use the time dilation effect caused by gravity. Take a spacecraft close to a black hole, fly around it for some time, and then return. These methods are theoretically feasible, but before our technology reaches a much higher level to cruise in the galaxy, they are just sci-fi movies on the screen. In order to stay healthy and live longer, it is more practical to pay attention to health conditions, improve medical science, and protect our environment. On the other hand, if human civilization has the ability to cruise within the galaxy, let's imagine the subjective feeling caused by time dilation. In order to gain intuitive understanding, assume that your interstellar voyage has achieved a time dilation effect of 5 times by circling around a black hole. In other words, 1 year on the spacecraft is equivalent to 5 years on the Earth. So, if the spacecraft sails for 10 years, when you return to the Earth, you will find that 50 years have passed on the Earth. If you get a physical checkup, you will find body functions have aged 10 years only, and people living on Earth are 50 years older. If your spacecraft can maintain communication with the Earth, then on average it will receive news of 5 days on the Earth for each day on the spacecraft. All things on the Earth will literally occur much faster. Certainly there will be a huge delay in interstellar communications because electromagnetic waves travel at the same speed of light, so it will take time to receive updates. In comparison, let's imagine the spacecraft cuts off the communication with the outside world. The crew will not receive any message from the Earth. In that case, objectively time dilation still occurs, but subjectively people on the spacecraft will not have a direct feeling that time has slowed down 5 times. Of course, this does not include the psychological impact of homesickness. From this thought experiment, we can see that the input speed of external information about the Earth's reality, compared with your surroundings and your body's biochemical functioning rhythm, may be the source of the subjective feeling for the speed of time flow. Your awareness of time passage comes from the outer world. In this imaginary story, if you leave the Earth in the year 3000, the Earth time should be 3050, but the atomic clock in the spacecraft has only passed for 10 years. Although the difference in time readings is very obvious, you will not go to the future of the Earth because of this. You will only return to the present of the Earth, and the present of the Earth is 3050. What has happened on the Earth seems to have fast-forwarded at 5 times your time. Moreover, you cannot go back in time to live in the past. You could only watch and read the information from the media such as the Internet. However, you may be able to get some level of experience through VR. From our regular perspective, past time corresponds to things that have passed, present time corresponds to things that are happening, and future time corresponds to things that have not happened yet. Sometimes we know what will happen, especially over a long time horizon, but still it has not become the reality of the world. The outline of a story still misses tangible details and subjective feelings. We wait for reality to set in. It is as if you order a delicious steak in a restaurant, but the chef is still cooking it back in the kitchen. You may even hear the sizzling sound, but it is not ready to taste it. We keep experiencing the transition of reality from now to the future, and put the past into our memory. Now represents the reality of the present, rather than the specific numbers of year, month, day, hour, minute, and second. As mentioned earlier, under different conditions of motion, speed, and celestial gravity, the specific rhythm of time, expressed by traditional clocks, atomic clocks, or biological clocks, may vary a lot due to different degrees of time dilation. Einstein famously said, "The distinction between past, present, and future is only a stubbornly persistent illusion." This sentence comes from a condolence letter he wrote to his friends and family in 1955. At that time, his best friend Besso had just passed away, and he himself left this world 1 month later at the age of 76. He did not directly say time does not exist, but said the separation of past, present, and future is an illusion. We cannot go back in time to interview him about this sentence and ask him whether he really believes scientifically that the past, present, and future of time are indistinguishable. If his answer is yes, then further to ask whether these three exist or change at the same time. Based on his block universe theory, his answer may be, most of the time reality has already happened. After all, the future of time and reality is not totally random, but predictable to a certain degree of probability. Time came to 2009. Dr. Stephen Hawking, sitting in a wheelchair, held a welcome party for time travelers from the future. Dr. Hawking deliberately waited until the reception was over before sending out invitations publicly. Future time travelers should be able to see the invitation and travel back in time to surprise him. Unfortunately, no time traveler showed up as he figured. Probably Dr. Stephen Strange has been too busy to come. The idea of time travel has definitely brought a lot of inspiration to the filming industry around the world. Next, we will ask if time does exist and real. This translates whether reality really exists. At present, mainstream physics believes that the universe originated from the Big Bang 13.8 billion years ago. That is the starting point of time and space. In recent years, cyclic cosmology has been developed, such as the conformal cyclic cosmology proposed by Roger Penrose, believing the universe cycles from expansion to contraction repetitively, and these cycles may overlap or separate in time and space. Some people believe the universe is not unique, and that our universe is just a big bubble, suitable for biological lives. There are also theories for parallel time and space. It is interesting to hear that somewhere exists another version of us. A more subversive theory tells us we live in a virtual reality, created by higher intelligent beings. As we know, human senses, including vision, hearing, touch, etc., can be simulated and generated using electronic signals. The rapid development of artificial intelligence, quantum computing, virtual reality, and brain-computer interface makes people believe that in the future it should be possible to create highly simulated virtual worlds, and human consciousness can also live in one of them.
What's outside the simulation?
From a simplified logical or philosophical perspective, everything can be built upon information, and time is a variable used to describe the rhythm and causality in the sequences of information flows. The ultimate materials in this world are information and energy and matter can be converted to each other using Einstein's mass-energy equivalence equation and remain overall constant. Energy can also be described and manifested by information as reality. This seems especially true if the world is virtual, or when total energy is constant. The creation and causality from information and energy might be what Buddhism refers to as the quality of emptiness, or Taoism refers to as the Tao.